I'm going to go through completing a square and how to do it. So completing a square or writing in polar form. So just as, kind of a talk through how to do it, what's the method, and I've got the 3 sort of types you can get asked. Okay, so the first one is the most straightforward one. So they all start the same way. We take the x coefficient, which in this case is -6, we half it, which gives us -3. And then we square it, which is 9. So then what we want to do is rewrite the quadratic, and then we want to add the 9 and minus the 9. So overall we're not changing it at all. Now essentially what we're trying to do here is we're trying to write this as a square. So what we're going to end up with is like something squared. Sorry, I have written that, hang on. There, like that. Or maybe it might be x minus a squared. Okay, but something like that. So I just want to very quickly go through this. So just to be clear, that if you have something like x plus 2 to be squared, that would be x plus 2, x plus 2. That would be x times x plus 2 plus 2 times x plus 2, which is x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4. Okay, so in these questions, what you're going to have to be able to do is quite readily move from here back to here. Okay, now, just to kind of clear this out, to get from this to this, to get from the 4 to the 2, what you do is you square root the 4. That's how you figure out what value that is. So whatever that third term is, you just square root it, and that brings you back to the 2. And then the only other thing you need is basically whatever answer, or whatever, sign is there, that's going to match the sign up here. There you go. Okay, and then if we look at the negative version, so if we have x minus 3 to be squared, and I do that one out, it's going to be x minus 3, which is x times x minus 3 times x minus 3, which is x squared minus 3x plus 9, which is x squared minus 6x plus 9. So again, in these questions, we're going to be going from the bottom to the top. So to get from the 9 back to the 3, we will have to square root the 9, which works here. And then I told you the last time that whatever sign is in the middle of the quadratic will match the sign in the middle of the square. Okay, so whatever sign is in the middle of the quadratic, so on the 6x, sorry, I have added that in, just isn't coming up. There you go. So whatever sign is on the 6x, that will match the sign in the bracket. All right. So based on that, we're going to form a quadratic, and we're going to do that using the x squared, the minus 6x, and the plus 9. and we're going to turn that into a perfect square, just like, well, backwards of what we did on the right there. So we have x squared minus 6x plus 9, and then I'm going to leave the minus 16 and the minus 9 separately. Okay, so I want to write this bit here as so I want to write that bit there that I've underlined. There you go, as a perfect square. So the way we do it is we have our x that goes in the first position. To get this spot here at the end, we're going to do the square root of the 9. So whatever is there, we're square root that. So the square root of 9 is 3. And then whatever sign, very slow, whatever sign is in the middle, that's the sign that goes in here. Yep. And then we have the minus 16 minus 9, which is minus 25, I think. So then from there, hopefully you've already done transformations of quadratic graphs. So from there, you should be able to figure out that the minimum turning point is 3 minus 25. So you change the sign. You change the sign on the 3, or in this case the minus 3, and you keep the sign on the minus 25. All right. Okay, so that's kind of the most straightforward version. This version here then has a coefficient, so it has a number in front of x squared. It has a number in front of x squared. So same method. We take the coefficient on x, which in this case is a 4. We half it, which is a 2. Sorry, I'm just checking why the internet's so bad. And then we square it, which is 4 again. Okay, so we write out our quadratic as it is, 2x squared plus 4x minus 7. And then that number we've just generated, we're going to add it and we're going to minus it. I need to form my quadratic again using my 2x squared, my 4x, and my positive number that I brought in. So it's going to be the plus 4. I'm going to bring them together. So I get 2x squared plus 4x plus 4. And then I have minus 7 and minus 4. So now that I have that, I'm going to once again use the trinomial. So these 3 here. But I can't get a perfect square out of that because it has the 2 in front of it. So I'm going to take that 2 out. So it's going to be 2 times x squared plus 2x plus 2. Okay, because when you take a number out like that, you are dividing by 2. Then on the end, I have the minus 7 and the minus 4. So that is minus 11. Okay, so now I need to make a perfect square out of what's in the bracket, but what's there is not a perfect square because if you remember, to get the perfect square, I would need to square root whatever is in that position, and that 2 is not a perfect square. So I need to change it to something that is a perfect square. Now, the only perfect square smaller than 2 is the number 1. So what I'm going to do is I'm going to change that 2 into a 1 plus 1. Okay, so I'm going to change the 2 into a 1 plus 1. And now I'm going to make my perfect square out of those 3. Okay, so this is essentially what I'm setting up. Okay, I'm going to turn the 3 into a perfect square, and I still have my plus 1 and I still have my minus 11, which hasn't changed. Okay, so the x is the x. To get this bit here, I do the square root of that number there, which in this case is a 1, and the square root of 1 is 1, so that goes in there. And then for the middle, I just match the sign there, so that's going to be a plus. Okay, and then all I want to do is expand, or not expand, multiply out these brackets. So this by this by this. So I'm not going to actually do the first multiplication. So I have 2 times x plus 1 to be squared, plus 2 times 1 is 2, and then I have the minus 11. So then last line is 2 by x plus 1 to be squared minus 9, and I can get my minimum turning point to be minus 1 by changing the sign of the number in the bracket, and then keeping the sign of the number outside is minus 9. That's the minimum turning point. Okay, and the last one, the issue here is that it's negative. So first thing I'm going to do is just rearrange it. So it's minus, just putting the x squared first, the x second, and the number last. Yeah? Other than that, it's the same thing. I take my x coefficient, I half it, and then I square it. So take the minus 4, half it, you get minus 2, square it, you get 4. Then I write down my minus x squared minus 4x plus 3, and then I'm going to add 4 and I'm going to minus, I'm going to add 4 and I'm going to minus 4. Now, every time we've taken the plus version into our we've always taken the plus version into the quadratic that we're going to turn into a perfect square. This time we're going to take them, this time we're going to take the minus, okay? And the reason for that is because we have a minus in front of the x squared. That kind of changes how we're going to handle the next part of the question. So for these ones, we're going to take the minus. So I have minus x squared minus 4x minus 4 plus 3 plus 4. So I'm going to take these 3 at the beginning there, and I'm going to take out the minus 1. So that means I'm going to divide here by minus 1, I'm going to divide here by minus 1, and I'm going to divide here by minus 1. So that gives me x squared plus 4x plus 4, and then at the end I have plus 7. I'm going to keep the minus 1, I'm just going to write it as a minus, and then this here should become a perfect square, I think. So the x is the x. To get the bit here, the last part of the bracket, I square root the 4. Square rooting the 4 gives me a 2. And then I take the sign from the center and I just put it down here. So that's going to be plus. Now, because this is a negative x squared graph, so up here there's a minus on the x squared, because it's a negative x squared graph, that means the graph is n-shaped, which means the turning point or the vertex is not at the bottom, it's at the top. So it's referred to as a maximum turning point or a maximum vertex. You get it in the same way though. You switch the sign on the number that's in with the x, so it becomes minus 2, and you keep the other sign, so minus 2, 7. Okay, so I know that was a bit glitchy in coming through, but hopefully that made sense. And that's how you complete the square. Oh, I don't know if that auto-corrected, sorry. So the question will either say complete the square, or it will say write in vertex form, or it will say find the minimum turning point or the maximum turning point. Okay.